Good afternoon, class. It's Sir Capistrano again, and welcome back to Physics 1 General Physics. And for today, we'll be looking into another concept here in physics. So, this concept is what we call momentum, impulse, and collisions. Uh, medyo relate, familiar sa inyo. It is one of the most familiar topics regarding physics because we intuitively know this by intuition alam natin na at some cases yung mga bagay-bagay na mas mabigat, mas mabilis, mas ganito ganyan ay mas mataas ang nagiging momentum. So, momentum, impulse, and collisions are actually just extension of what we already learned about kinematics and dynamics and mechanics. So, yun yung next na topic natin. This is just medyo nearing na tayo rin sa end ng ating physics course. So, for today, we'll be taking it a little bit lightly. So, going into our discussion itself, let's look into momentum and collision, momentum, impulse, and collision. So, sabi ko nga kanina, medyo familiar ito. So, kumbaga, halimbawa, meron kang dalawang sasakyan. Kasi, yan, pagpasensya nyo na yung drawing ko. But in any case, we have here two vehicles and one of the vehicle is relatively heavier than the other. So, we have here a truck with a mass of 5,000 kilograms and car with a mass of 1,500 kilograms. So saying that they are moving at some velocity or some velocity, we know that if the car and the truck travels in the same velocity, we know that the truck will actually have a higher momentum than the car. Kasi yun yung expectation natin, yun yung intuitive nating iniisip. Though, hindi lang natin basta-basta agad naka-quantify or hindi lang natin agad napagtutuunan ng pansin kung paano natin nasasabi yun. So, by definition, a momentum is actually given by this formula. So, as you can see here, we have here momentum is actually represented by a small letter P with an arrow. So we can say that it is actually a vector quantity. So momentum is actually equal to the mass of the moving object uh, multiplied to its velocity. So ang sinasabi lang natin dito when we talk about velocity here, yung velocity is actually in the same direction ng ating momentum. Okay? So dito natin actually nasasabi na mas mabilis or mas mataas yung nagiging momentum ng isang bagay kung siya ay mas mabigat. So, kumbaga, if we are to give a certain example here, say, both of the vehicles are moving at the same velocity. Let's say the velocity of the truck is equal to 2 meters per second, and also the velocity of the car is 2 meters per second. Given that they have the same weight, we will know that the truck will actually have a higher momentum than the car. So kasi pag kinumpute natin yan, if we have this momentum of the truck, so we have here mass is 5,000 kilograms. If we are to multiply that to the velocity, which is 2 meters per second, so we will have here a momentum which is actually 10,000 kilogram meters per second. So, at this point, class, sabihan ko kayo na huwag kayong malilito ha. Huwag kayong malilito na ba ibig sabihin ko. As you may see here, we have a unit which is kilogram meters per second. Hindi po ito equal sa Newton because as you may have remembered, Newton is actually kilogram meters per second square. We are missing the square there. So, how about the momentum of the car, let's say? So, as the problem states, we have there a mass which is equal to 1,500 kilograms. And if we are to multiply that to 2 meters per second, we will only have a momentum which is actually 3,000 kilogram meters per second. So it is relatively lower by ilang percent na ito? Almost 325% na ba ito? O 333%. Yung difference ng kanilang magiging momentum. So, ano pa ba yung pwede nating tingnan dito? Actually, we can relate momentum with the second law of motion of Newton. So, for those of you who may remember that, uh, our force or our by second law of motion, we can actually write force as the mass times acceleration. So, pwede natin i-relate actually ang ating momentum with force in this note because as you may have remembered, we can actually write this equation in a form like this. So we will have here, since mass is hindi natin gagalawin yan, acceleration is actually equal to our change in velocity over change in time. Okay? So in that note, kung makikita niyo dito, we can actually rewrite this in a way that force will be equal to the change in mass times velocity over change in time, which is actually just equal, kung titingnan nyo, we have here mass times velocity. That is actually our momentum. So we can actually rewrite this as the change in momentum over change in time. So we can rewrite our force to be equal to the change in momentum over the change in time. This also relates to the fact that yung iniisip natin that we will be requiring a lot more force to stop an object with higher momentum. Kasi sinasabi natin to be able to change that high momentum papuntang low momentum will be requiring a lot of force. So, kumbaga, kung isusulat natin yan, we can actually rewrite that in a way na ang mangyayari, we have there to change the momentum, this is equal to our force times the change in time. Meaning to say, we will be requiring a lot more force to change a certain quantity of momentum na sobrang laki. Okay? So, dyan na pupunta or dyan yung thinking natin or yung reasoning natin kung bakit iniisip natin na halimbawa, merong dalawang sasakyan at mas mabigat yung isa, parehas sila nagta-travel at the same speed and they need to stop immediately. You will be requiring a lot more force to stop the heavier vehicle than the lighter vehicle. So, yun yung ating momentum. Okay, in that, let's continue on with the discussion of impulse. So, by impulse, ang pwede nating tingnan actually when we talk of impulse is it's somewhere between the distinction of changing a certain momentum of an object. So by changing a momentum of an object, by definition, an impulse is actually, let's just write here. Impulse is actually used to describe or quantify the effect of force acting over time to change the momentum of an object. It is represented by the symbol J and is usually expressed in Newton seconds or kilogram meters per second. So kung titingnan natin, parang yung sa ano lang din, ano, nung pinag-usapan natin yung work at saka yung ating work and energy. So same sila ng ginagamit na quantity. But for this, impulse is actually the change. Uh, it is the effect of force acting over time to change the momentum of an object. So, kumbaga, basically, this is the change in momentum. So, kumbaga, halimbawa, meron ka ditong rubber ball At yung rubber ball mo, gusto mo siyang, ibinato mo siya sa wall at the horizontal direction. Okay? And throwing that at horizontal direction, usually, nagba-bounce off yung bola na yan, pero hindi na kasing bilis nung, nung, nung time or nung initial throw mo. So, ano nangyayari doon? So, basically, as the ball touches the wall, ang nangyayari dito, kung isipin natin at a nick of time, yung sobrang liit na, let's say, halimbawa, ilang milliseconds, there is actually a force that counteracted the movement or the momentum of this ball towards the wall. Kumbaga, na-squish siya dyan, and due to the elasticity of the ball, it will bounce up. So, yung contact time na yun, tinatawag natin contact time na yun or time of impact na yun mismo. Halimbawa, sabihin natin 0.2 seconds yung impact na yun. Uh, yung force na nag-exist doon sa area na yun or yung force na nangyari doon sa collision na yun or doon sa pagbangga ng bola natin doon sa wall, that is actually that can be quantified by our impulse. So, paano ba nag-work yun? So, basically, ang impulse is that is characterized by the letter J, capital J, is actually the force na kailangan nating or the effect of force that acting on an object over time to change the momentum. So, yan yung ginagamit natin. So, it is a force multiplied by time. So, as you can see here, this is actually equal to Newton second. And if express natin yung Newton in units, that is kilogram meters per second square. Then, i-multiply mo siya sa second. So, maka-cancel yung isang second mo dyan. So, that will be equal to kilogram meter per second. So, as you can see here, this is actually similar with our units ng momentum natin. Ang kaibahan lamang na change in momentum yung ating impulse. So, paano ba natin i-express yun? So, as you may have remembered earlier, I stated that force can be written this way. So, yung impulse natin, that will actually be our change in momentum over change in time. So, times change in time, and as you may see here, this can actually cancel out, meaning to say our impulse is just equal to our change in momentum. So, paano ba natin yon i-represent dito sa example nating bola? So, for example, you have an initial velocity for the ball, which is actually equal to 10 meters per second. And nung mag-bounce off siya, nangalhati yung velocity niya. So, you have a final velocity which is equal to, say, 5 meters per second. Okay? So, kumbaga, if you don't know na yung impulse mo, ay pwede mong express in our change in momentum, hindi natin yan basta mako-compute kasi hindi naman binigay sa atin yung force. Unknown yung force na ginamit natin. Ang alam lang natin ay yung speed ng bola. Say, you have a contact time, yung mismong paglapat lang ng bola dun sa wall, pabalik. Say, yung contact time na yon ay equal lamang sa 0.002 seconds or 2 milliseconds. Okay? So, paano natin ngayon mako-compute yung ating yung tinatawag nating force or halimbawa gaano kataas yung impulse or ano yung impulse natin dito sa system na to. So what we can do here is actually just get the change in the impulse. So by change in the impulse, which is equal to our J, we will have here yung ating initial momentum, no, final momentum, minus our initial momentum para makuha natin kung gaano kataas yung impulse or kung gaano kadaming force yung na-apply dun dun nung bola papunta ron sa wall or nung wall papunta ron sa bola. So what we can do here is use the formulas wherein we will have here the mass times the velocity, the final velocity of the ball, minus the mass multiplied to the initial velocity of the ball. So knowing na magaan lang usually yung rubber ball natin, let's say it has a mass of 0.1, 0.10 kilograms. So let's compute this. So we will have here 0.10 kilograms multiplied to initial, which is final, which is 10 meters per second, minus our 0.10 kilograms times 5 meters per second. Okay, ganun lang pala kadali, ano? Ganun lang pala natin siya gagawin. So, pag na-compute na natin to, tapos na. But actually, class, it's not. Kailangan mo rin i-consider yung mga directions natin. Since the ball initially is moving from right to left, and it bounced back from left to right, we can actually write this in a way na parang x-axis lang natin. We will be using negative. We will be considering the initial velocity to be negative and the final velocity to be positive. So what will happen here? Ay, oo nga, no, napagbaliktad ko. In any case, di ba? Kailangan natin mag-ingat sa mga yan. So, we will have here 5. Yan yung ating final. And we have here negative 10 as our initial. So, what will be the change in our velocity? Or change in our momentum? So, we will have here 0.10 times so that will be 0.5 kilograms meters per second minus negative 1 meters per second. So that will be positive. So we will have here 1.5 kilograms meters per second. So that is our impulse. It just means that per second we'll be requiring 1.5 kilogram 1.5 newtons. So, paano ko nasabi yun? So, basically, gawa lang nung impulse natin mismo. Ibig sabihin lang, this 1.5 kilograms meters per second is actually the effect of force acting on an object per second. Okay? So, that is our impulse. So, paano yan kung gustong malaman yung force mismo? Say, you want to compute for the force that is applied from the wall towards the ball. So, paano natin gagawin yan? So, what we can do here is we just use this formula, itong kanina, itong definition natin ng impulse. So, what we can do here is we just write that J is equal to the force multiplied to that change in time. So, the change in time, as you may have remembered, is our 0.2 seconds. And our impulse is actually 1.5 kilograms meters per second. So, gaano kalakas daw yung force na in-apply nung wall towards dun sa ball during this collision or during this impulse. So, what we can do here is since yung movement natin ay punta sa positive, I guess we will have here positive force. So, what we can do here is just write our 1.5 here, 1.5 kilograms meters per second. And we have here our force, which is unknown, and our change in time, which is 0.02 seconds. Okay? Then, mako-compute na natin yung force. Wherein yung force, move ko lang to ha. Wherein our force will actually be equal to 1.5 kilograms meters per second divided by our 0.02 seconds. As you may see here, you will have second square here. So we'll have 1.5 divided by 0.02. So that will be equal to 75. So we will have here 75 newtons or 75 kilograms meters per second square. Sabihin, the wall applied 75 newtons towards the right dun sa ating 0.10 kilogram na ball. Okay? So that is how we can compute for the force that affected the change in momentum. Or in yung change of momentum natin ay nagkaroon tayo ng 1.5 na change in momentum mula ron sa negative na uh, ilan yun? 1 meters per second. So that is the change. Yun yung change natin sa momentum. Okay? So for the next part of our discussion, we'll be looking into, actually, this is the last part of our discussion. We'll be looking into collisions. And by collisions, this actually is relevant to what we call yung medyo related din dun sa ating thinking nung ating sa energy or yung tinatawag natin. For this one, we'll be actually looking into the conservation of momentum. By conservation of momentum, we will actually be talking about the total momentum in a system. So, kumbaga, if we are to talk about the momentum of the system, if we have here, say, for example, we have here two billiard balls. So, we have here the cue ball and the nine ball. Kapag nagbanggaan itong mga 'to, we'll be actually looking into the conservation of momentum. So, we can actually look into kung gaano bang momentum yung nag-e-exist dun sa system natin. So, as you may notice here, I actually use billiard balls instead of other rigid bodies or other moving bodies na medyo tragic yung mga pangyayari or by tragic, medyo nakakalungkot yung mga pangyayari like collisions ng halimbawa ng isang car or ng isang truck sa wall, collision ng pagbangga ng moving car sa moving na 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 truck, anong pwedeng nangyari, anong magiging velocity, ano yung magiging tatalbog ba yung kotse, yung mga ganong scenario. Imbes na ganon, let's more into a more classical and controlled set of collisions na pwede nating makita. So ano pa ba yung iba nating pwedeng tingnan na collisions na related dito sa conservation of momentum? We can actually look into halimbawa, kukuha ka ng mangga na nasa taas ng puno at wala kang panungkit. So, ang ginawa mo, meron kang bato na may certain mass, ibinato mo ron sa mangga, tinamaan mo siya head-on, gaano kabilis yung pagtalsik nung mangga pag tinamaan mo siya. So, pwede mo rin gawin yon or pwede mo rin yung tingnan sa scenario na to. So, for this scenario, let's say we have here this cue ball. Usually, yung sa mga na tumitira sa ilalim ng bato, when we talk about billiards, we actually have this cue ball na halimbawa, anong nangyayari, yung 9 ball na yung patatamaan mo, we actually point the taco o yung billiard stick towards the direction of kung ano yung target mo. So, you have object in rest, tapos patatamaan mo siya, ano yung magiging collisions natin. So, umaga, halimbawa, during its movement, itong ating cue ball, binangga niya yung 9 ball, during that movement, anong pwedeng mangyari given its collision? So, kanina, bago ko i-record ulit itong discussion na ito, I actually looked into the average mass ng mga billiard balls and usually sabi nila it's between 156 to 170 grams. So for this one, let's just assume that we have here the mass of the balls, parehas na ball ay nasa 0.160 kilogram or that is actually equivalent to our 160 grams. So let's say before nung collision, The billiard ball actually has an initial velocity na sabihin natin, sulat ko siya, VI is equal to, say, 2.0 meters per second. Okay? Tapos, syempre, yung 9 ball natin, yung initial point niya or initial position ng ating or initial movement ng ating 9 ball, since patatamaan mo nga lang siya, is 0 meters per second. Then, nung after nung collision, nagkaroon siya ng final velocity na, let's say, at pala binago ko yung kulay, ano. But anyway, mamaya baguhin natin. Let's say yung final velocity niya ay, say, 1.5 meters per second. Sabihin natin yun. Okay. Ang gusto mong malaman ngayon ay kung ano yung magiging velocity or final velocity ng cue ball mo. Kasi syempre, after ng collision, hindi naman yung basta mag-stop. Or pwede siyang mag-stop, pero ito ba yung scenario na yun? So, hindi natin ngayon alam kung ano yung magiging direction nung cue ball na yan. So, pupunta ba siya sa left? Pupunta ba siya sa right? So, paano pag dead on yung collision? Ano nangyari? Saan siya pupunta? Titigil ba siya? So, pwede natin actually gamitin yung ating conservation of momentum to do that. And in that, actually, by conservation of momentum, we just need to account for this equation. So, for any body or any system, the the sum or the total momentum of a system, let's say the sum of all the total momentums, okay, or initial momentums, will be equal to the sum of all our final momentums. Ibig lang sabihin yan, bago nangyari yung collision, yung momentum nung buong system ay dapat magiging equal doon sa after collision. So, ito, sinasabi natin, ito ay before collision, this is after collision. So, ano lang ang gagawin natin dito? So, in that, we can actually account for the two movements here. By two movements, pwede natin gawin, we can actually account for the initial momentum ng ating cue ball. Sinulat ko siya na 0 kasi cue ball plus yung initial momentum ng ating 9 ball. Let me just change the color of this writing para malaman natin, ano. So, the initial momentum of the 9 ball will be equal to the final momentum of our cue ball, final, 0, plus yung final momentum din ng ating 9 ball. So, yan lang yung ibig sabihin natin dyan sa conservation of momentum natin. So, kung walang external impulses, walang external forces na nag-prevent dun sa motion ng ating nung cue ball at 9 ball, yan yung ideal na magiging system. So, para magawa yan, dyan natin makukuha actually yung final velocity ng ating cue ball using this formula. So, saan natin makikita yon? So, as you may have remembered by the definition of momentum, momentum will be equal to the mass times the velocity of the object in motion. So, what will happen here is we will have here our mass of the cue ball, so that will be MO, multiplied to our VIO, or the initial velocity of our cue ball, plus our 9 ball, which is mass of the 9 ball, times the initial velocity of our 9 ball, equal to the final mass, which is hindi naman magbabago. We'll have here final velocity of our cue ball, plus the final momentum of our 9 ball, which is equal to its mass 9, VF9. Okay, so in here, we just need to substitute all of our values to this equation para makuha natin yung ating final velocity. And in here, actually makikita na natin mamaya kung ano yung magiging direksyon ng ng velocity na yan mismo. So let me just plug in all of the values. So we have here a mass, the mass of the cue ball, which is 0.160 kilograms. We just need to multiply that with the initial velocity of our cue ball there, which is 2.0 meters per second. We just need to add that to the initial momentum of our 9 ball. And as you may remember, we have here a zero velocity, making this whole equation zero. So, hindi na natin siya i-consider muna for now. Then, we'll have here our mass of the cue ball again, which is 0.160 kilograms ulit. And we just need to multiply that to our unknown, which is actually our VF0 plus yung ating final momentum ng ating 9 ball, which is 0.160 kilograms, and we need to multiply that to that final velocity, which is 1.5 meters per second. So in here, kailangan na lang natin itong i-compute. So as you may see here, meron lang tayong mga paglilipat na gagawin. So, we will have here yung 0.160 multiply lang natin sa 2. So, based dun sa calculator ko, if we have 1.60 multiply natin sa 2, that will be 0.32. Okay? Yung pinupit ko. Okay? So, we will have here 0. Ay, bakit dilaw? So, we will have here 0.32 kilograms meters per second minus, bakit minus? Kasi ita-transpose natin dyan. So, we'll have yung dito naman. So, this will be 0.24 kilograms meters per second. That will be equal to 0.160 times kilograms times yung ating final velocity. So, nangyari dito, we will have 0.08. I'm not mistaken. So, this will be 0.08 okay, kilograms meters per second, and we will have here 0.160 kilogram no, times yung sa ating final velocity ng ating cue ball. So, as you may have remembered dun sa mga past discussions natin, all we need to do here now is just divide this by 0.160 kilograms. Then, maka-cancel out natin yung kilograms dun sa kabila. So, this will cancel out. And if we have 0.080 divided by 0.160, so we will have there 0.5. Okay? So we have here 0.5 meters per second. And as you may notice here, positive siya. So, ibig sabihin, yung bola natin or yung ating cue ball will be actually following the direction of the 9 ball since it will be moving to the right. Okay? So, that is our collision or yung tinatawag nating conservation of momentum. So, para dun sa mga cases na gumagalaw na yung system natin, magpa-follow lang din yan ng the same step. Okay? We will still be using this conservation of momentum wherein instead na magiging zero lang itong portion na ito, magkakaroon lang tayo ng value dito and the same goes, magpa-follow lang yun ng system na yan and you will still be able to compute for the direction and the magnitude of your final velocity. Okay? So in that, I will be ending this lecture here, wherein we already talked about our momentum, impulse, and collisions using some ideas na medyo light at mas madaling consume or mas madaling ma-absorb. So in that, I will be ending this pahabol lecture here. Thank you and have a great day. Bye-bye.